Actually interesting that you can find the 4 roots of a complex number. Let me show you on a picture what we're talking about. So here's your complex plane. This is your real x and your imaginary y times I. Okay? So if we go over negative square root of 2 up square root of 2i, I'm going to be right here. All right? And we want the 4 roots of that. Well, the 4 roots are probably going to be maybe straight across here, maybe straight across here, something like that, I would guess. What do you think the distance is between these compared to each other? We labeled these A, B, C, D. How do you think AB compares to CD in the distance? Do you think it's the same? How about BC and AD? Well, today you're going to prove that. You're going to do that with some actual values, but we're going to just try to visualize this for now. So here is what we're starting with. Here's my point, Z. What we want to do first is X is the real part, negative square root of 2. Y is the imaginary part. Do we include the I in it? We don't, because this is X plus YI. X plus y times I. Well, the I is already covered, so y is square root of 2. So then you got to find r first. Square root of x squared, which is 2, plus y squared, which is 2. Square root of 4 is 2, like that. Theta, well, if this is straight, you can tell this is straight in the middle here, 45 degrees. What arc length is it from here over to there? 3 pi over 4. Now, if you're having trouble with that, this is your unit circle. I'll draw the unit circle here. And then this was 0. This was pi over 4. This is 2 pi over 4. So what does this one have to be if it's right in the middle there? 3 pi over 4. All right, so here we go. Let's do it. So now what we have is z to the 4th, because we're going to find the 4 roots, is going to be r, which was 2, cis 3 pi over 4 plus 2 pi k, because we're going to have multiple values. I gave you a hint yesterday. I strongly recommended that you replaced this this thing with a denominator, get the same denominator. So you have 3 pi plus 8 pi k all over 4. All right, so now we're all set to go. Z0, Z1, Z2, Z3. There's 4 roots, so that's going to be fine. Put a 0 in for k and you get, oh, I'm sorry. Whoa, I'm not done yet. I got to get rid of this. This is going to be 4/4, 1/4, 1/4. So this is going to be 2 to the 1/4, and this is going to be 3 pi plus 8 pi k over what? 16, yeah. So here we go. This is going to be cis 3 pi over 16. That's the first one. The next one is 2 to the 1/4. Cis 8 plus 3 is 11 pi over 16. And then you're going to get 2 to the 1/4. Cis. Now we're going to get 2 times 8 is 16, plus 3 is 19 pi over 16. And the last one is 2 to the 1/4. Cis. 3 times 8 is 24, 27 pi over 16. Those are the 4 roots. Yes. You really should. You really should. So what Walker is talking about here is that Z2 is 2 to the 1/4 cis 19 pi over 16. Now that's bigger than pi, and it's actually not legal. So we're going to subtract 2 pi. How many pi over 16 is that if it's 2 pi? 32. So 19 minus 32, I think, is negative 13. So you're going to get negative 13 pi over 16. Is that right? Is that right? And then the other one, Z3, is going to be 2 to the 1/4 cis 27 pi over 16 minus 2 pi, which is how many pi over 16 again? 32. So 27 minus 32, is that negative 5? That'll be negative 5 pi over 16. Woo! Those are the 4. And I think you're right. Well, that's just a different problem. I thought that was the answer. I know these are right. So here's these two. 3 pi over 16, 11 pi over 16, and then negative 13 pi over 16, negative 5 pi over 16. Now, some people that are so clever, and I know you're out there, what they do is instead of going, once you get this one, Z1, it's close to pi, they go, I'm going to try doing a negative 1 for k. So what's 3 pi minus 8 pi over k? There's your negative 5. And then I'm going to try a negative 2. So what's 3 pi minus 16 pi over k? There you go. So you could get it that way too. Either way is fine. And tell you the truth, if you get these 2 answers and these 2 answers, I'm going to be pretty happy too. But to be correct, it needs to be between pi and negative pi.